overhauls on the fly. My name is Mike Davidson. I've worked aboard and inside some of the most incredible machines on Earth. Now I'm going back in, digging into the guts and bolts of these machines to discover how the hard hat heroes who keep things running make it all happen. This is Impossible Repairs. They may seem old-fashioned, but trains still make the world's economy go. So on these tracks, time is money. % of Europe's goods move by train, just as cargo has since the 1800s. So it's time to catch one. SBB Cargo is one of Europe's busiest haulers, pulling over 50 million tons of cargo across the continent each year. I'm heading out on a 1,000-kilometer freight route that will take $1 million worth of cargo from a busy container yard in Busto, Italy, through the Alps in Switzerland, across a labyrinth of tracks in Germany, and then on to the port of Rotterdam in the Netherlands. And at the center of it all is the Vectron locomotive. Since each country has its own electrical system, locomotives have to change systems when they cross borders. But the Vectron is versatile. Because the SBB train has a different current collector for each of the 4 countries it travels through. When it's working, and right now, this one isn't. Which is why we're already stopping for repairs. Because even new equipment can get damaged, and shipping cargo by train is a surprisingly rugged business. One of the most vulnerable parts of the locomotive is the Pantagraph, the mechanism on top of the locomotive that pulls power in from the electrical lines above. And ours is busted. Thousands of amps of electricity run through these trains. That much current has the power to obliterate. The 7,000 horsepower Vectron locomotive travels at a top speed of 160 kilometers per hour and draws power from above with its Pantograph. The Pantagraph is 4.5 meters high and pulls in up to 25,000 volts of electricity, enough to power 200 houses. But it's fully exposed to the elements, and with voltage like this moving at high speeds, anything that gets in the way can cause major problems. It's also what conducted an arc of electricity, powerful enough to punch a hole through the roof of this locomotive. Our train leaves in just 12 hours, so time is tight to get this loco ready. The first step is to remove the old Pantagraph. It's bolted onto the loco.
Pantographs are built light, so when an incident like this one happens, it's the pantograph that breaks and not the line. that would be a much more serious problem.
A new Pantagraph costs $18,000. Fixing a power line is $11,000 a minute. Quite a difference. Next up, we catch the hole on top and bring in the replacement part. An $18,000 price tag means handle with care. Pantagraphs have two carbon contacts that conduct electricity from the lines above to the train below. The engine's good to go, but we still need the cargo. Claudio's taking a separate engine to pick that up, 35 kilometers away across the border in Italy. On this journey, we're moving 50 wagons of diesel fuel, oil, batteries, and consumer goods worth about $1 million and weighing in at more than 1,000 tons. Now loaded up, Claudio hauls the cargo back to Chiasso. Where it's transferred to our newly fixed locomotive. Claudio's day is done. Now the cargo will sit overnight, awaiting its departure window.
I hook up the locomotive now that the Pantograph is down.
Early the next morning, driver Alvaro Martignani takes over.
We start off about an hour before we can leave so we can get the locomotive ready. Then, we hook up all of the wagons, check that they're secure, and get ready to go.
It's all packed into 50 wagons, and we have to check every one of them. Disconnecting on the tracks would be an epic disaster. With 3 countries and hundreds of kilometers left to haul this cargo over, we need to keep to the schedule. He's checking to see if the brakes are engaged. It's not dancing on Broadway, but footwork here is just as important. But just as we're ready to pull out, work using air pressure. When a train is moving, air flows through lines on the bottom of the wagons, which are connected to the locomotive's air compressor. The air in the brake lines is controlled by a set of valves in each wagon. When an emergency stop is triggered by the locomotive's computer, the valves close and switch to air from a reserve tank in the wagons, which engages the brakes, locking the train in place and stopping our train before it even starts. If we can't move our $1 million load, we'll miss our departure window, which can cost thousands of dollars in wasted manpower on the trains and waiting cargo ships.
We're ready now, and we've been given the signal to depart.
When in doubt, restart it. The emergency brake has released its grip, and we can hit the rails.
We've left now and we're good. I'm checking in the camera that the train is behind us and it's working.
After a 2-hour delay, we're finally departing from Chiasso, Switzerland, and headed through the Alps to Basel, then on to Cologne, Germany, crossing into the Netherlands at Venlo, before finally arriving in the port city of Rotterdam. 50 kilometers into our journey, the computer is still reporting a problem. Albero is hauling 1,000 tons of freight at 100 kilometers an hour. He's worried about the brakes as we head into the Alps.
To make sure that the brakes are working, you have to feel how the train brakes.
So we're stopping at the next station for a system check.
As soon as I see my colleague, I'm going to update him about the performance of the train.
While our train is inspected, there's no rest for me. I'm going ahead into Europe's largest mountain range, the Alps. At 1,200 kilometers, the Alps are the longest, highest, and most extensive mountain range that lies entirely in Europe. About 100 mountains in the Alps are taller than 4,000 meters. At almost 2.5 kilometers beneath these mountains and 57 kilometers in length, it's a marvel of modern engineering. Before the tunnel's creation, trains like Albero's had to haul themselves up and over these gigantic mountains. But why go up and over when you can go straight through? I'm going into the Gothard base tunnel to get a preview of my trip. And to see inside some epic infrastructure. At 57 kilometers, Gotthard is the world's longest and deepest railway tunnel, and it goes directly through the Swiss Alps. It cost over $12 billion and took 7 years to build, and 9 lives were lost during its construction. The tunnel is solid, but the elements are unpredictable, so constant maintenance is important to keep everyone inside safe. We're not going quite that fast on the work train, but this tunnel is built for speed. The number of components in need of upkeep is staggering. 10,000 lights, 500 kilometers of drain pipes, and over 300 kilometers of rails. With traffic set to roll through here again in 4 hours, there's no time to spare. It's all headed up by Thomas Good. He's the guy in charge of the maintenance for the Gotthard line. Wear and tear is so tough, they have to close the tunnel once a week for safety maintenance. When the Gotthard was built, they created sections where there are 2 tunnels and bypasses to protect anyone who gets trapped inside. trains weighing 1,000 tons or more need to change tracks within the tunnel. The rails shift at these junctions. But the rails are only a few centimeters wide, so when they shift, the movement has to be exact so they join seamlessly. Even being off by mere millimeters could be the difference between life and death on these rails. If things do go wrong though, designers of the tunnel have included a way to seal off the damage from anyone else on the tracks. When the maintenance crew comes in, they bring a pair of huge 8-meter-high safety doors to seal off a section of the tunnel, guarding against wind, smoke, fire, and other trains. The train has finally passed inspection, and my buddy Claudio is back to pull our cargo, along with 7 extra wagons weighing in at 1,400 tons, through the Alps. Considering our previous brake issue, Claudio is being extra careful. Long, heavy trains like this can be lethal for anything that gets in their way. Moving at about 100 kilometers per hour, it takes a massive amount of braking power to stop these heavy haulers. When a train is loaded down with 1,400 tons of cargo, it's like a very heavy, speeding bullet. So if the driver applies the brakes here, it will take the length of 9 football fields to bring it to a stop. Which means drivers need to see accidents before they happen. With $1 million cargo load behind him, earlier brake issues, and the confined space of the tunnel ahead, Claudio is preparing for the worst. Our 1,400-ton train started its journey with brake problems. As railway tunnel in the world. Claudio needs to do a crucial brake test, because if they malfunction inside the tunnel, the results could be lethal. Claudio reaches our cruising speed of 100 kilometers per hour, and he slowly presses on the brakes to see if they engage. Will they work? The brakes engage. Success. The tunnel cuts directly through the Alps and is almost 2.5 kilometers underground at its maximum depth. Space down here is limited. We'll be under the mountains for the next 57 kilometers, then push on another 120 kilometers after the tunnel to Basel Station. Freight trains and 65 passenger trains use the Gothard base tunnel on a daily basis. That works out to nearly 11,000 people and over 100,000 tons of freight speeding along these rails every day. A journey that used to take hours going around or over the mountains is now completed in a little less than half an hour. As the sun goes down, Claudio pulls into Basel, the train's last stop in Switzerland, before we move to another track for the trip through Germany. But getting on the right track is harder than you think. This system sends air pressure through the train's central brake line, so that even when the wagons are disconnected, none of the 1,400 tons of cargo moves a millimeter. Our cargo will sit here until morning, and then be sent on to Germany. It all happens here in Basel. Shunting means pushing or pulling cargo from the main line to another track. And I'm getting a behind-the-scenes look at how it's done. The actual hill the rail yard is built on is tiny, but the maze of tracks is immense. Hundreds of thousands of wagons move through here each year as they head across Europe. At the heart of the operation are shunting locomotives. Big engines that push freight onto the right track, headed for its destination. I love this place. It's the real-life version of the toy trains I had as a kid. Shunting locomotive coming in hot. From here, they push the wagons down this small hill and let gravity go to work. unlike my toy trains, this yard has a braking system integrated into the tracks. So if the wagons get going too fast, they can drop the speed in an instant. This deserves a closer look. Mechanized rail brakes installed on the tracks grip the wheels of the wagons, reducing their speed. Once slowed, the wagons are distributed to locomotives headed across Europe. A quick push of the pipe unlatches the wagons from each other, so they can head to their final destinations, unless some greenhorn sends them in the wrong direction. Now that it's made its way through the rail yard, our load of cargo is back on the move, heading towards Germany. But I'm not going with it. Instead, I'm traveling to a stretch of tracks near the town of Olten, Switzerland, to see some heavy machinery in action. A tamping machine is designed to repack the ballast, the rocks that hold the tracks in place. The ballast can last up to 20 years, but the tracks need regular maintenance. Every 3 minutes, heavy trains give these lines a major beating, smashing and compressing the sleepers, fasteners, and metal rails under the weight. Each time this happens, a train's huge momentum pushes the track slightly out of alignment. Without proper maintenance, over time, misalignment can turn into warping, which can be incredibly dangerous for trains traveling at high speeds. That's where one of SBB's 23 tamping machines comes in to save the day.
It's a very modern machine. This is a continuous tamping, straightening, and leveling machine in one. At this moment, this is one of the most modern machines that can do all of this together.
The tamping machine maintains different sections of the rails almost every night.
So the first part registers the levels of the tracks through the lasers. The second part is the lifting and straightening. Then, after comes the tamping and compressing. And in the back comes the leveling machine, so that the tracks are clean of the ballast. The machine operator, the one who tampers, he sees the paint when he's driving.
This sci-fi monster is about to meet its match. This $1 million tamper could be busted. There are big problems with the tamping machine. The tamping machine was about to seriously damage the junction point in the tracks, known as a rail switch. This switch moves the rails so that a train can shift from one set of tracks to another. The hammers on this tamping machine were dangerously close to ripping this rail switch apart and destroying the undercarriage of the machine in the process. So the crew makes an adjustment. To accommodate the rail switch. A split-second decision just saved tens of thousands of dollars in additional repairs. Been maintaining the rails. Our cargo has crossed the border from Switzerland and is on its way through Germany, stopping now in Mannheim. Driver Jonas Niederberger has been riding these rails since he was 19 years old. In his 20 years of hauling heavy cargo and dangerous goods, the goal has always remained the same.
The challenge is to transport goods safely and on time to the destination.
Due to problems earlier in the journey, the train is hours behind schedule.
I just want to drive. At the moment, we have to wait.
But there are strict speed limits and guidelines for making sure drivers adhere to all safety requirements.
I have to pay attention to the speed and make sure I brake on time.
The locomotive is equipped with sensors to ensure that drivers are always engaged in the action.
The vehicle monitors me with a pedal and a footwell. If I become incapacitated for any reason, the train won't continue driverless. It'll be stopped automatically.
It's a system called the dead man switch that automatically stops the train if a driver fails to hit the pedals at regular intervals.
I have to press the pedal every 30 seconds.
This system, which is installed on trains all over the world, saves lives. On April 28, 2010, a New York City subway driver had a heart attack while driving his train. With no pressure on the controls, the dead man switch was activated, stopping the train and saving his subway cars from a possible collision. Our cargo is now rolling across Germany, and then on to the Netherlands, where I'm waiting for its arrival. But now, power becomes an issue, because trains crossing the border into this rail yard have to change to a totally different electrical system. The locomotive can handle both systems, but it can't deal with both at the same time, so it has to make the switch from AC to DC. DC, or direct current, uses lower voltage electricity than AC, or alternating current, to drive the motors. But to switch to the DC system, they'll have to lower the pantograph. So, the locomotive will be without power until it connects with the new source. If a driver fails to brake just right, he gets stuck in an electrical no man's land. Perfect braking. Stretch. From the junction in Venlo, we're traveling 190 kilometers onto the port at Rotterdam. We're on board with driver Thomas Schmidt for the last leg of the journey. His supervisor, Freek Hilkemeyer, is along for the ride to fill me in on what's happening during the trip. Is clearly not just the land of windmills and tulips. It's also home to one of the most important freight hubs on the planet. Nearly 500 million tons of cargo goes through the port of Rotterdam every year. So it's like rush hour in the rail yards every hour of the day. Less than half an hour from Rotterdam, there's bad news. The power's out at the port, meaning there's no place to deliver our load. These delays are costly for SBB Cargo International and for the ships anxiously awaiting the $1 million worth of cargo we're pulling. Get the okay from train control to line up outside the port. But that will have a ripple effect on the dozens of trains behind us. Hundreds of trains roll through this port every day. If the power isn't fixed fast, it could cost every train and waiting ship Thousands of dollars in wasted labor every hour. Unpowered line is open at the port, so we can transfer our load over to a diesel locomotive, unless we get caught behind too many other trains. Transferring our wagons to a diesel locomotive, which will take this load the final 8 kilometers. Meaning our $1 million cargo can still catch a ride on the outbound ships. A 1,000-kilometer freight run, riding the rails through 4 different countries.